Day 14 of 90, and today we're building something real, a contact book CLI in Go, from an empty file to a working tool. Here's why this matters. Most learners know the syntax but freeze the moment they have to design a multi-field data structure. They reach for flat variables or an untyped map, and 3 requirements later the whole thing is unmaintainable. By the end of this video you'll have a clean contact struct, a map-backed store with proper lookups, and a command loop that behaves like an actual service. Let's go. Start with the bug that bites everyone. You write a lookup, somebody asks for a contact that doesn't exist, and instead of crashing you get back blank data, empty name, empty email, served like it's real. That's Go's 0 value. A missing map key does an error, it hands you a zeroed struct. So our whole design has to respect that behavior instead of fighting it. We'll fix it with one idiom, but first, let's model the data properly. Here's our struct, type contact struct, name string, email string, phone string. 3 typed fields. Compare that to map, string, stringly typed, no structure, and the compiler can't catch a typo like email. With a struct, c.email is a compile error, caught instantly. Now add a constructor that validates at creation, func new contact, name, email string, contact, error. If name is empty, return an error right there. Bad data never enters the system. That's the payoff of typed fields, the compiler and the constructor are both working for you. Now the store. We define a name type wrapping a map, type contact book struct, data map, string, contact. Wrapping the map in a struct gives us a clean API boundary, callers go through methods, never touch the map directly. Initialize it with contact book, data, make, map, string, contact. Forget that make and you get a nil map, and writing to a nil map panics. So our constructor builds the map every time. This name type pattern is exactly how you'd wrap an in-memory cache in a microservice later. CRUD time, and here's where the OK idiom saves us. Func, b** contact book, get, name string, contact, bool, return c, OK, equals b.data, name. That OK is a real boolean, true if the key existed, false if not. The caller checks if OK, return errors a new, not found before ever touching the data. No more silently serving blank contacts. Add is the same discipline, check if OK equals b.data, name, OK first and reject duplicates. Delete uses the built-in delete, b.data, name. Every operation guards the 0 value trap. List needs one extra touch, determinism. Ranging over a map in Go gives you a random order every time, which is awful for output you read or test. So collect the keys into a slice, sort strings, keys, then range over the sorted slice and print each contact. Now your list is stable, same contacts, same order, every run. Small habit, huge difference when you're debugging or writing tests against the output. Wire it to a CLI. A Bufio.newscanner, OS/din, reads commands in a loop. Split each line, switch on the first word, add, get, delete, list and dispatch to the matching method. Each method already returns an error, so the loop just prints it, if error equals nil, fmt-ln, error. Notice we built 0 interfaces. Method receivers on our named map type gave us a complete, clean API surface. Interfaces come later, when we have multiple implementations, don't reach for them before you need them. Let's run it live. Go run main.go. Add 5 contacts: Alice, Bob, Carol, Dave, Aaron. Type list, and they come back sorted alphabetically. Delete Bob. List again, Bob's gone, the rest hold their order. Now look up someone who isn't there, instead of blank garbage, we get a clean not found. That OK check is doing exactly its job. The tool feels solid because every edge case has a defined answer. Day 14 done. The takeaway, type structs plus a map wrapped in a name type, guarded by the OK idiom, gives you a clean, extendable service, and this exact pattern scales straight into an in-memory cache layer in a real microservice. Subscribe for day 15.
you.